All right, thank you so much for joining us today. So let's look at questions on differentiation of vector function. So we are trying to differentiate a vector function. So stay here with me and let's go through together. Now, the very important thing that we need to know with this example that we are going to do here is this, right? We need to know that the velocity is actually the r over the t. Now the r here, we are talking about the position vector, right? Or the parametric equation. And then the when you differentiate the parametric equation two times, you are going to get the acceleration. Or when you differentiate velocity, because since this is the same as velocity, then when I differentiate a velocity, I need to also get what? The acceleration, because this means that this is equal to what is here. So what we mean here is something like this. This is the same as the t open bracket dr over the t. Is that right? So you will see that since we are differentiating it two times, it means that we need to differentiate this again. So we are trying to differentiate this. And we know that what is inside the bracket here is velocity. So this is going to give us d over dt v, right? And this is going to give us dv over dt. Yeah. So basically, these are the two things that we need before we start the examples. Good. So here we have a particle and we have the parametric equations. We want to find the velocity and then acceleration at the time. So before we do that, first we need to form the parametric equation. Let's call it, let's say, r of t, because this is in terms of t. So we are going to have something like r of t, which is equal to xi plus yj plus zk. As we know, anytime you have it in this form, this is a parametric equation. So what is x? X is given to us, y is given to us, and z is also given to us. So our function here will be equal to e to the power negative I, negative ti plus 2 cos 3t j plus 2 sine 3t k. So now this is the parametric equation, right? So what we just need to do is now we want to find the velocity. So let's assume that this is equal to v, and we know that this is the same as dr over dt. So we need to differentiate the function. You will talk about, okay, we've done differentiation already, so you know how to do differentiation. I thought you are in level 100. Okay, so this is, we know how to do differentiation. So we are going to differentiate this term by term. That's what you are going to do. So we are going to differentiate this and differentiate this and differentiate this. So that's what you are going to do. So this is the same as d over dt open bracket e to the power minus ti plus 2 cos 3tj plus 2 sine 3tk. Good. So now let's differentiate it term by term and see what we are going to get. So when I differentiate an exponential function, what am I going to get? So we say that for exponential function, maintain the function and differentiate what is on the top. So when I differentiate what is on the top, I'm going to get minus 1. So when I do that, I'm going to have minus e minus ti, right? So I maintain the function and I differentiate what is on the top, which is minus 1. Then now I need to differentiate this. Now if I want to differentiate cos of 3t, I need to use the change rule, right? This is a composite function. So first, when I differentiate the cos function, what am I going to get? I'll get sine, or let me say minus sine, right? Then when I'm done differentiating the cos, now I need to differentiate what is inside the bracket with respect to t, and this is going to give us 3. So that's what we are going to get. So it means that this is going to give us minus 6 sine 3tj. So we are doing composite differentiation. Differentiate cos, it is going to give us minus sine. Then when I differentiate what's inside the bracket with respect to t, I will get 3. 3 times 2 will be 6. Then plus, same thing here. When I differentiate sine, I'm going to get cos. So sine 3t will give us cos 3t. But when I finish, I need to differentiate what is inside the bracket, which is going to give us 3. I'll multiply this 3 by 2 here, and I'm going to have 6 cos 3t k. So this is the velocity, right? Which is v, So that's the first question that the question was asking us. The next question is to find acceleration, right? So for us to find the acceleration, we need the v over the t. It means that for us to talk about acceleration, we need to differentiate the velocity function here, right? So now we are going to differentiate this and we are going to get the acceleration. So let's do that. Differentiating this again. Now what am I going to get? This is basically something like d over dt, open bracket, minus t I minus 6 sine 6 3t j plus 6 cos 3t k. So here, when your differentiation is very good, it's kind of very simple to do that. So let's differentiate this. What we get now, the same thing, I maintain the function and differentiate the top. So when I differentiate the top, I'll get minus. So it means that this one will come back to e to the power minus ti, right? So what did I do? I have minus this, and this is going to give us minus. Then I differentiate what is on the top, which is going to give us minus 1. So when I multiply, then it becomes positive. Then minus 6. And when I differentiate, we differentiate this. When I differentiate this, I'm going to have sine 3. This is going to give us 3 cos 3t, right? So when I multiply the 3 to the 6, I'm going to have 18 sine 3tj. Let's look at the last one, which is cos. So when I differentiate cos 3t, I'm going to have minus 3 sine 3t. So you should be able to be good with this kind of differentiation. So differentiate this is going to give us minus sine. Then when I differentiate what is inside the bracket, I have that. So this is going to give us another minus 18 sine 3t k. I had 18 here because 3 times 6. Good. So this is the acceleration, right, with respect to time. So this is velocity, and this is the acceleration. Okay, let's look at the next question. So the next question is, we are going to continue for, so this is A, this is B. Find the magnitude of the velocity and then acceleration. So we want to find the magnitude at time what? T is equal to 0. So we know that velocity is equal to, from here we saw that we have something like minus e minus ti minus 6 sine 3t plus 6 cos 3t. Now we all know that if we want to find the magnitude, then we need absolute of v. But since the question is saying that at time t is equal to 0, then it's best for us to evaluate it at t is equal to 0 before we find the magnitude, so that it becomes so simple for us. So let's do that. So I want to do it at t is equal to 0. So this is minus e. So when I put 0 there, this one becomes 0, I minus 6 sine. When I put 0 here, 3 times 0 will be 0 plus 6 cos. When I put 0 here, 3 times 0 will be 0 2 again. So now what is e to the power 0? 1, right? So this is going to give us minus I. And then what is sine 0? Sine 0 is 0. So everything here goes to 0. And what is cos 0? Cos 0 is 1. So we are going to have plus 6k. So now that we have gotten something like this, then now we can find the magnitude. So the magnitude of Vn at t is equal to 0 will be now equal to. Now you know that for us to find the magnitude, we just need to pick the coefficient of the directions. So we are going to have minus 1 squared plus 6 squared, which is going to give us 1 plus 36, and this is going to give us root of 37. Very simple. Now same thing we are going to do with, we are going to do the same thing to acceleration. So we know that acceleration was equal to e to the power minus t I minus 18 cos 3tj minus 18 sine 3tk. So that's what we had from this, right? That's what we had from here. So if that's the idea, then we do same thing. We find this at 0. So this is going to be e to the power minus e to the power 0I minus 18 cos 0j minus 18 sine 0k. So this is going to be I minus 18j. And this will blow up to 0 because sine 0 is 0. So now let's find the magnitude at t is equal to 0. This is going to be 1 squared plus minus 18 squared. And this should be giving us something like 1 plus 324. And this is root of 325. And this is like something is 5 root of 13. So it's kind of very simple here when you are dealing with, velocity and then acceleration. Just differentiate. If your differentiation is very good and learn how to do magnitude, you are okay to go. So that is basically what we just need to do here. Let's look at another one here. Here we want to show that velocity is perpendicular to our parametric equation, that is r of x or r of t. This is in terms of t. So now what we need to know here is we need to pay attention to this. So we have omega and t, but omega is constant. So it means that the function is in terms of what, t. So now for us to show that something is perpendicular, then we need to show that when I multiply Vn to r, I should be getting 0. So I have my r here, I need Vn. And we know that Vn, which is the velocity, is equal to dr over dt. So we just need to do that. So let's differentiate r and see what we are going to get. So cos omega t I plus sine omega tj. So let's do the differentiation. So as I said, if your differentiation is very good, you are good to go. So when I differentiate cos, I'm going to get minus sine. When I finish, don't forget to differentiate what is inside the bracket with respect to t. So this is going to give me omega. So this is going to give us minus omega sine omega t I plus, when I differentiate sine, I get cos. But when I differentiate what is inside, it will give me omega. So I'm going to have omega cos this j. So basically that's what I'm going to get. Now I have the velocity, I have my r2. So let's do the multiplication and see what we are going to get. So we want to multiply Vn to r. So Vn is minus omega sine omega t I plus w, which is omega cos omega t j times r. R is cos omega t I plus sine omega t j. So let's do the multiplication. So we know how to do dot product, right? We multiply directions. So these are the bases from there. So I'll multiply this one to this. What am I going to get? I'm going to have minus omega sine omega t cos omega t. So don't forget here I times I is 1. Good. And plus, then I'll multiply the j to j, right? So this is going to give us omega sine omega t cos omega w. So now we can see that this one here is the same as this one here, and this is minus and this is positive, so it's going to just cancel out and you are going to get just 0. So that's what you are going to get. So this is going to give us 0, and this shows that the velocity is perpendicular to the parametric equation or the position vector. Yeah, so this is question A. Let's look at B. So B is saying that we need to show that the acceleration is directed towards the origin. So when you say directed towards the origin, let's assume that we have our function r of x, which is going this way. So basically what we just want to do is we want to show that this acceleration is heading towards the origin, like we are heading towards the origin here. So the direction is now coming down, and if r is going up and this is coming down, then this is the negative. So it means that when we find acceleration, we should be getting negative. Good. Now we are using the same example here. So since we know velocity to be equal to this, we just differentiate this and then we get acceleration. So let's do that. So we saw that velocity is equal to minus omega sine omega t I plus omega cos omega t j. So let's find acceleration. Acceleration is equal to when we differentiate velocity with respect to t. So let's differentiate this. What do we get? So remember, omega is constant, so we just need to differentiate sine. When I differentiate sine, I'll get cos. When I finish, I need to differentiate what is inside. So this is going to give us minus omega squared cos omega t I. So I differentiate sine, I get this. I differentiate what is inside, what is going to give me omega. Since I'm multiplying, I'll multiply the omega to omega and I get omega squared. Same to this one. This is going to be minus because when I differentiate cos, I'm going to get minus sine. So this is going to give us omega squared sine omega tj. So you see that it's just moving from one to the other one. So let's see what is going to happen here. We have minus omega here, we have minus omega here. I can factor it out. So when I do that, I'm going to have minus omega squared, then cos omega t I plus sine omega t j. Now, one thing that we need to know here is that now this function right here is what was given to us as r of t, right? So cos omega t sine omega t. So it means that I can write this one as minus omega squared r because this is equal to r. Now, since omega is constant and is squared, it means that no matter the value of omega, if omega is minus, minus 1 squared will be positive. So it means that because we have minus here, the acceleration is always negative. This shows that the acceleration is moving towards the what? The origin. Then the question is also asking us to then the origin and has a magnitude proportion to the distance from the origin. So let's see. If you want to look at this one, if you want to look at the magnitude, then the magnitude of this is going to be something like this. Now the magnitude, we just need to work within this. So what I'm going to do is, since we are finding the magnitude, we are going to have something like this, minus omega squared or squared because it's a constant. So we can even ignore it and just bring it out, but I need to bring it there. Then I'll have cos squared because okay, let me write it fully. So I'll have this one being squared plus sine omega t being squared in bracket like this. So that's what I'm going to get. So I was just picking the coefficient of I and j, right? And then I did this one. This one is multiplying this, so I just need to, it's just a scalar. So I just need to square it because of the minus. That's the reason why I need to do this. So this is going to give us square root of omega to the power 4, because when I square the negative, it will be positive. And then in bracket here, I'm going to have cos squared omega t plus sine squared omega t. But we know that cos squared plus sine squared is equal to 1. So this is going to give us omega to the power 4 times 1. And this is the same as omega to the power 4 square root. And this can be written as omega squared squared, right? So that this will cancel this, and we are going to have this one to be omega squared. So you can see that this is just kind of constant, which is showing that it is what? The proportion, which is just using it, the proportion which is here, heading towards the origin of the plane. Good. Good. Let's look at the C. The C is we want to find R cross V, right? So what was R? This is R, and then this is V, right? So let me just copy them and write them here. So we know that R is equal to, let me see, cos omega I plus sine omega j. So it means that if I'm doing differentiation, this one will be minus omega sine omega t I plus omega cos omega tj. So this is what we just need to do. So I need R cross V, right? So remember, with cross, we need I, J, and K. So we can see that with the term here, all the J term, all the K terms are 0. So let's just pick the first one. R will be cos omega t, and then sine omega t, and this one is 0 because we don't have the K term, because this is kind of like plus 0k plus 0k. And then this is minus omega sine omega t omega cos omega t and 0. So we know how to do the cross, right? With the cross, always you can think of picking the smart approach. I can just pick this column here, because if I pick this column here, I just need to do the first one and everything here goes to 0, right? But if still you want to pick the first row, it's also okay. So this is going to be, not forgetting our cofactors. So if I'm using the top one, I can just write the top cofactors. So I'm going to have I times, so I cancel this, I cancel that. So I'm going to have sine omega t 0, omega cos this 0. Then minus j, because this is going with this. And when I cross this one, I'm going to have cos omega t 0, then minus omega sine omega t and 0. And then the last one that we just need to do is plus k, and k is going to cancel the 0 out, and we are going to have cos omega t sine omega t minus omega sine omega t, and then omega cos omega t. So as I said, you see, when we do it this way, the I direction will go to 0, because this time this is 0 and this time this is 0. So it's going to be like this is 0 minus j. This time this is 0, this time this is also 0. So minus 0. So it's going to be left with only the k direction. So I'll multiply this to this and this to that. So I'm going to have, when I multiply cos to cos, I'm going to have omega, I'm going to have omega cos squared omega t minus, right, minus this times this. So this is basically another minus because we have minus there, sine squared omega, right? So this goes to 0, this also goes to 0. So we are going to have something like this, k, and then I'm going to have omega cos squared omega t plus omega sine squared omega t. So now I can factor omega out. So I'm going to have omega k, then it will be left with cos squared omega t plus sine squared omega t. Now this property, we are going to use them a lot. Anytime you see cos squared plus sine squared or sine squared plus cos squared and they're having the same angle, then it's 1. So this is going to be omega k, and this is going to just give us omega k. So one thing that you need to know is whenever we are dealing with this type of questions, you should be having this in mind. It happens a lot in this kind of questions. All right, let's look at question 3. So given the parametric equation, this and that, we want to show that when I find the acceleration, because this is the acceleration, plus, then when I multiply omega squared to r, I will have it to be 0. So let's just go through quick. I wanted to give it to you, but I'll solve this one. Let me see whether I need to give you one to do. Okay, let me solve this one and give you the question 4 to do. So now d squared r over dt squared is basically the acceleration, right? So that's what we need. But for us to do that, we need to form the parametric equation. So this is going to be xi plus yj, which is the same as a cos omega ti plus b sine omega tj. So what is the r over the t? So the r over the t is equal to, so we are differentiating this again, cos. So this is going to give us minus a omega sine omega ti. So don't forget, we are using change rule. So when I differentiate cos, I'm going to have minus sine, right? Then when I finish, I need to differentiate what is inside with respect to t, which is going to give us omega. So that's the reason why I have it here. Then plus, same here, differentiate sine, you are going to have this. Same change rule there. Then since we need the second derivative, which is the acceleration, I will differentiate it again. So now let's differentiate this one again. When I differentiate sine, I'm going to get cos. So I'm going to have now minus a omega squared cos omega ti. So I just have this here, but when I differentiate sine, I'm going to get a cos. But when I differentiate what is inside, I'll have omega. So when I multiply omega to omega, I have omega squared. Same will happen here when I differentiate. But now when I differentiate cos, I'll have minus. So now the sign here will change to minus b omega squared sine omega t j. So this is what I'm going to get for this. Now what I need to do is now I need to multiply omega squared to this and see if when I add to this, I'm going to get 0. So let's look for omega squared r. So this is my r. Let's multiply through by omega. So I'm going to have a omega squared cos ti plus b omega squared sine omega tj. Is that true? So I'm just multiplying omega through by this. So when I multiply through by omega squared, I have this. Multiply through by omega squared, I have this. So now what we need to do is when I add this to this, I should be getting 0. So let's see if it's true. So d squared r over dt squared plus omega squared should be giving us 0. So let's see. So this is equal to this. So I'm going to have minus omega squared cos omega ti minus b omega squared sine omega tj plus a omega squared cos omega t I. So I'm adding plus this, which is this plus this, then plus b omega squared sine omega tj. So we can see that this is the same as this, and we can also see that this is the same as this. So this is going to give us a big zero, which shows that indeed it is equal to 0. Good. So I'll leave question 4 for you to do it and leave your answer in the comment section. So we have the parametric equation here. Find the velocity and then acceleration. And B, show that the acceleration is in direction of r at t is equal to 0. So basically, this is not asking you anything difficult. When you are done finding the acceleration from here, plug in when t is equal to what? 0. And the answer should be positive so that it will be in direction with this one. So basically, that's what you are going to do for question 4. Let's solve the last question, which is question 5, then we are done with this video. Yeah. So we want to show that when I find the magnitude of r, I'm going to get what? A. So first, let's form the r, right? So this is having 3 directions. So r of t is equal to s of t I plus y of tj plus z of tk. So I'll write this one simple as r. Then what is x? X is a cos omega ti plus y is a sine squared omega t j plus a sine omega t cos omega tk. This is a lot. So we want to show that now, remember this a here is not acceleration. This a here is the constant which is inside this. So the question is saying that if you find the magnitude of this, we are going to have it to be we are going to have it to be equal to what? A. So let's see if that is true. Let's find out. So let's find the magnitude. Magnitude of r is equal to, so I pick the coefficient of ijk and just square it. So the coefficient of this is a. So what should I do? Let me just do something simple that we can just use it to do it. So here I can factor a out because I can see that a is here, a is here, a is here, right? So that it becomes very simple when we are dealing with this. So cos omega t I plus sine squared omega tj plus sine omega t cos omega tk. So when you are dealing with this and anytime you see a constant and you are finding the magnitude, you can just bring the constant out, right? So since this one is a constant, like this one is a constant, I'll just bring the constant out. Then so I'm going to have just a out. So a out. So basically that's what I'm going to do. For example, what we did here, we saw that when we are finding the magnitude for this one, I could have, this is a constant, I could have brought it in front by ignoring the what, the negative, and just writing this, as we were able to even prove that this one was equal to just what is just here. So whenever you are dealing with, whenever you are solving a question which goes with a constant and you are finding the magnitude, you can just factor it out. So now basically I need to square this, this and that. So I'm going to have cos squared omega t plus, when I square sine squared, I'll have sine to the power 4th for this plus, now when I square ab, I'm going to have x squared b squared. So it means that this is going to be sine squared omega t cos squared omega t. Good. So this is what I'm going to get at the end of the day. Now let's try and simplify this. So we are going to have a square root of cos squared omega t plus, now here I can factor sine squared out, right? So when I do that, I'm going to have sine squared out omega t. This one will be left with sine squared omega t plus cos squared omega t. I left my omega t here. Do you get it? Here, I just want to factor sine squared out. So since this one is 4, when I factor 1 out, it will be left with 2, right? And when I factor this one out, it will be left with this. Now, as I said, we should be noticing this a lot because this repeats itself. This is going to give us 1. So it means that we are going to have a square root of cos squared omega t plus sine squared omega t times 1. Now, what are we going to get here? This is a square root of cos squared omega t plus sine squared omega t. Again, we can see that this is going to give us 1. So this is square root of 1, and square root of 1 is 1, and this is going to give us a. So indeed, when you find the magnitude of r, we are going to get a. A is not acceleration, it's the constant which we are referring here. Let's do the last question, and then we are done here. Now, here is saying that we should find the velocity and an acceleration. And when we are done, when you multiply these two, we should be getting 0. So let's find out if it's true. So velocity is equal to dr over dt. So what was our r? Let me just copy the r and then just send it there. Let's go and work with that. So r is given like this from the question. So let's just do the differentiation. So as I said, here your differentiation must be very good. So let's differentiate this. I differentiate this using the change rule, right? So when I differentiate cos first, I'm going to get minus. So this is going to be minus a omega sine. So you see that some of the function will be differentiated before. And when I differentiate this, this one here is like a power function with a change rule. So this one can be written as sine omega t all squared. So for us to do this, this is how the differentiation is going to be. First, I will apply the power rule. So this is what I'm going to get. I'm going to have 2 sine omega t. And when I subtract 1 from this one will be 1. So it's just to the power 1, which is this. Then now times, then I will differentiate what is inside the bracket here, right? So when I differentiate what is inside the bracket here, I'm going to have cos omega t times, then I differentiate what is inside the bracket here, indeed, which is omega. So this is going to give us 2 omega sine omega t cos omega t. But don't forget we have a also here, So this is going to give us plus 2a omega sine omega t cos omega t. Good. So that's what we are going to get from the differentiation. Now the last one, we are going to use the product rule because we have sine and cos. So I'm going to use the product rule. This is just a constant, so I will leave it there. Later on I'll multiply it through. So with the product rule, I will let big A to be equal to sine omega t and B to be equal to cos omega t. Now I need A prime, I need B prime. So what is A prime? When I differentiate sine, I'm getting omega cos omega t. Because I differentiate sine, I get cos. I differentiate what is inside, I get omega. Same thing to this. So this is going to be minus omega sine omega t. So product rule says that if I have two functions multiplying and I have the function itself and their derivative, then I just do cross multiplication. So I just multiply this to this and to this to form the derivative from there. So this is going to be plus, don't forget the a. So I'm going to have a out. Then this times this is going to give us omega cos squared omega t plus this times this is going to be it's supposed to be plus. So product rule we do plus, but this is minus. So this is going to produce minus omega sine squared omega t. Good. So here your differentiation must be very, very good. So let's try and simplify something here, and then let's see what we are going to get. So this is going to be minus a, right? And then sine omega t I plus 2a omega sine omega t cos omega t, then plus, so here I can factor omega out. So I'm going to have a omega out cos omega t minus sine squared. Okay, this is squared. Okay. Don't be in a haste to say that this is 1. This is not 1. When it is plus, that's when we say it is 1. So this is not 1. So this is what I'm going to get. Let me add the j to it, and this one should be going with k. So j, and this one should be going with k. So this is the velocity. Now let's find the acceleration, right? Let's find the acceleration. So acceleration is for us to differentiate the velocity. So we need to differentiate velocity we are going to get. So we differentiate it again. This is going to give us minus a omega squared cos omega t I, right? So when I differentiate this, this is going to give me cos. Then I differentiate what is inside, going to give me omega, giving me omega squared. Another one again, this is a product rule because we have two functions, right? These are constant, so I don't need them. So if I want to do it straight, then this is going to be this. So I just factor my constant out and do product rule with these guys. So when I maintain sine omega t first and I differentiate cost, I'm going to have times. So now I'm differentiating cos. I'm going to have times. When I differentiate cos, I'm going to have minus omega sine omega t. Right? This is what I'm going to get when I do that. Then plus when I maintain cos omega t and differentiate sine, I'm going to have omega cos omega t. This is a lot with j, right? So I was just doing the one that I use a b to do it. So I maintain this, differentiate cos, I'll have this. Then now maintain cos and differentiate sine, I'll get that. Then plus, I'm not done, plus a omega. Then when I differentiate this, so as I said, this is squared. So what is going to happen is I need to use the power rule and then the change rule. So this is going to give us 2 cos omega t. So I'm done with the power rule, which is the 2 here, right? Which is the 2 here. Now the next thing to do is now differentiate the cos function itself. So this is like cos omega t squared. So now I'm done differentiating the squared, which is giving us this. Now I need to differentiate what is inside. So what is inside is going to give us times minus sine omega t times, then I differentiate what is inside this, which is going to give us omega. Then minus, now I come here again, differentiate this with respect to t. So this is now sine. So this is, I have sine omega t squared. So this is going to give us 2. This is going to give us 2 sine squared. No, there will not be squared again. Omega t times Then when I differentiate the sign, I'm going to get cos omega t times omega. So this is kind of a lot here. Times omega. Good. So this is the final, this one. We just need to simplify it and then we are done. So I'll add the k to it. So let's simplify. I'm going to have my acceleration to be equal to minus a omega squared cos omega t I. Then when I simplify this, when I multiply this one through, I'm going to have plus 2 omega. This is going to give us minus omega sine squared omega t. Then when I multiply this one through, I'm going to have plus omega cos squared omega t j. Then plus a omega. When I multiply this one through, I'm going to have minus 2 cos omega t sine. Okay, I have omega again. So this one will be minus 2 omega. Then that. Then I have another minus 2 omega cos omega sine omega. This is going with k. So we can see that I think this term is the same, right? This term is the same. So when I simplify that, I'm going to have something like this. Acceleration to be equal to minus a omega squared cos omega t I plus this one. We cannot say that is equal to 1 because there's minus here. So I can factor omega out. So I'm going to have 2a omega squared. Then since this is minus, I'll swap this and this. So I'm going to have cos omega t minus squared minus sine squared omega t j. Then plus, or let me say, when I add this and this, I'm going to have minus 4 omega. Then when I multiply it to this, I'm going to have minus 4a omega squared cos omega t sine omega t, and I have my k. So when you add this and this is going to give us minus 4 omega of cos omega t sine omega t. Then when I multiply this one by this, I get minus 4 a omega times omega will be omega squared. So this is what we are going to get at the end of the day when we simplify. So the problem was this one. If this one was plus, could have simplified the thing for us. Very simple. So the last one that we just need to do is we just need to multiply this to this and we should be getting 0. So let's use I testing and see. When I multiply this one by this, and I multiply this one by this, and I multiply this one by that. So let me just do it here, okay? So we are just doing the last one. We want to multiply r to v and we should be getting 0. So let's see what we are going to get. So let me just copy my r. So my r is this, right? I want to dot it with my vin, and then we had vin to be this. Good. We had vin to be paste. So let me arrange it very well for us to see. No, it will not go there. Okay. So let me maintain it here. So we want to multiply this to this, and it should be getting 0. So with dot product, we multiply I to I, j to j, and k to k. So let's do that. I to I is going to give us minus a squared omega cos omega t sine omega t, right? So I just multiply this and this, giving us this, and then cos and sine is going to give us this. plus, then I multiply this to this, I'm going to have 2a squared. What am I doing? Okay, I'm multiplying. Good. So when I multiply this one to this, I'm going to have 2a squared omega. Then I'm going to have sine to the power 3 omega t cos omega t. So when I multiply this sine to this sine, it will be 3 here, right? And then I have my cos here. Then the last one will be plus. Now multiply this by that. I'm going to have, so this one is kind of like, let me try to like expand this. So when I'm trying to expand this, this term here will multiply this, and this term here will also multiply this. So this is basically something like this. AW going with this, and then A omega also going with this. Good. So let's multiply. This times this is going to give us plus A squared omega. Then when I multiply this to that, I'm going to have sine omega t cos to the power 3 omega t. Then plus, no, minus. Then this to this is going to give us minus a squared omega sine omega to the power 3 cos t cos omega t. Good. So that's what we are going to get. Let's see if we can do some considerations here. Let's see what is happening. Let's see what is happening. Can we cancel? I can see sine this and that and that and that and that. But this is 2 and this is 1. So when I subtract, I'll have one of them. So with this and that, we are going to have a squared omega sine to the power 3 omega 3 cos omega that. So when I just subtract this from this is what I'm going to get. Is this and this also related? Let's see if it is true. Okay. Not that true. So let's try and write everything down. Let's see what we are going to get at the end of the day. So minus or plus omega squared w sine wt cos to the power 3 omega t minus squared here omega cos omega t sine omega t. What are we looking for? You should be giving us 0. Okay, let's factor this and this out. So a squared omega out. Then I have sine here, I have cos here, I have sine here, I have cos here. Let me factor it out. So I'm going to have sine omega out, cos omega 2 out. So what is going to happen? Okay, let's see what is going to happen. So when I factor this out and this out, I factor one of the sine and cos out. This one will be left with just sine squared omega t, right? This is out here. This is also out here. And I factored this one, and it will be left with this. This guy is out here. This guy is also out here. And when I factor one of this from this one will be cos plus cos squared omega t. Then minus, when I factor this out here and also factor this out here and this out here, it will be just left with 1. Oh God, this is nice. So this is out here, cos is out here, sine is also out here. So this actually help us to see that this is 0, because now we can see something. So we know that sine squared plus cos squared is 1. So 1 minus 1, and this is going to give us 0. So sine omega t cos omega t times 0, and this is going to be 0. So something that seems to be not going to be 0 now is equal to 0. Yeah, so this is the end of the video, and see you in the next video.